Leaving behind the dusty plains of Mars, we now set our sights on the true giants of the solar system. Worlds that are not made of rock, but of gas and ice, pressure and storms. At infinity beyond, we consider this the gateway to a vastly different chapter of planetary science. Welcome to the realm of Jupiter. Jupiter is not just the largest planet in our solar system, it's a planetary titan. With a diameter of over 142,000 kilometers, nearly 89,000 miles, it could fit more than 1,300 Earths inside it. But Jupiter's size is only part of what makes it fascinating. It is a planet of extremes, an alien world whose atmosphere churns with immense storms, whose magnetic field dwarfs that of all other planets, and whose family of moons includes some of the most promising places to search for life beyond Earth. From a distance, Jupiter dazzles with its bands of red, white, and ochre. These bands are massive belts of high-speed winds flowing in opposite directions, encircling the planet like ribbons of cosmic energy. Between them rage enormous storm systems, the most famous being the Great Red Spot, a swirling anticyclonic storm larger than the entire Earth, which has been raging for at least 400 years. Unlike the terrestrial planets, Jupiter has no solid surface. Its atmosphere deepens gradually into a supercritical fluid, neither liquid nor gas, under immense pressure and heat. Beneath that may lie a core of heavy elements, but even that remains uncertain. The deeper you go, the stranger it gets: metallic hydrogen, electrical storms, crushing forces that science can barely replicate. Jupiter is also the solar system's protector. Its immense gravity serves as a gravitational shield, deflecting or capturing many comets and asteroids that might otherwise threaten Earth. This protective role may have been crucial in Earth's early history, allowing life to flourish in relative stability, while Jupiter swept the solar system clean of dangerous debris. But perhaps the most intriguing aspect of Jupiter lies not in the planet itself, but in its moons. Jupiter is orbited by at least 95 known moons, ranging from tiny, asteroid-like bodies to planet-sized spheres. 4 of them, the Galilean moons, Io, Europa, Ganymede, and Callisto, are worlds unto themselves, each with unique characteristics, mysteries, and potential for life. Among them, Europa has captivated scientists more than almost any other moon in the solar system. Europa is slightly smaller than our moon, but beneath its icy crust lies a vast global ocean, possibly containing twice as much water as all of Earth's oceans combined. At infinity beyond, we often refer to Europa as an ocean world, one of the most likely candidates for harboring extraterrestrial life, not on the surface, but in the dark, salty depths beneath its ice. In the coming years, NASA's Europa Clipper mission will embark on a detailed study of this enigmatic moon. It will orbit Jupiter and make dozens of flybys of Europa, scanning for signs of habitability, measuring its ice shell, magnetic field, and potential plumes of water erupting into space. These plumes could provide direct access to the ocean below, a rare opportunity to sample another world's subsurface ocean without drilling through kilometers of ice. Back on Jupiter itself, NASA's Juno spacecraft has been orbiting since 2016, collecting high-resolution data on Jupiter's gravity, magnetism, atmosphere, and auroras. Juno has already revealed that the planet's belts extend far deeper than previously thought, and that Jupiter's poles are home to swirling cyclones unlike anything on Earth. At infinity beyond, Jupiter represents a threshold, a world that challenges our understanding of planetary formation, chemistry, and even biology. It is not a place we will ever walk upon, but it is a place that has shaped everything around it, and perhaps sheltered the very origins of life.